Good day, my audience. We are still running the series on binomial theorem. We have solved the first, second, and third questions on the board. We are left to solve the fourth one. And the fourth one says, use the binomial theorem to approximate 1 all over the square root of 4.004 to 4 significant figures. Now, let us look at the problem from the eye of indices. If we look at it from the eye of indices and we set it in the proper way, it will now enable us to solve it. If I set 1 over square root of 4.004, if I set it as in brackets 4.004 raised to the power minus half by the law of indices, we can now look at this as separating the integer from the decimal fraction. It can look like an expansion. It looks like a binomial, it looks like an expression to be expanded. And then remember that if the fraction, if the index, if we have x plus y raised to power n, and n is a fraction or a decimal number, so to say, if n is a fraction or a decimal number, the formula we are meant to use is 1 plus x raised to the power n is equal to 1 plus nx plus n minus 1 over 2 factorial x raised to power 2 plus dot dot dot, meaning that the expansion continues. Now, if x is very, I use the word very, if x is very, very small, that is so insignificant that it is close to 0, then 1 plus x raised to power n can be collected into the form, can be used to approximate expressions, and can be collected into the form 1 plus n times x. Okay, this is called a linear approximation. We can use it in great effect to approximate expressions of this form. Now, if I separate, having separated this, you can see that if 4 is our whole number and 0.004 becomes our x, then x is very, very small. But we are not done with simplifying this bracket, because if we are to apply this expression 1 plus nx on this 4 plus 0.004, this form must become 1 first. So we go ahead to say 4 plus 0.004 all to the power minus half will become 4 raised to the power minus half in brackets 1 plus 0.001 raised to the power minus half. Now, this will give us, if we now take this into cognizance as this, okay, we're going to have 4 raised to the power minus half. 4 raised to the power minus half is what? Okay, 4 raised to the power minus half is the same thing as 1 over 4 raised to the power half, and 4 raised to the power half is 2. So we're having 1 over 2 here, and then for this expansion, from the approximation, we're going to have 1 plus our n, which is minus half. And then let me use block brackets here to differentiate it. Then this is our n, then our x is 0.001. Okay? Okay, so if I finish off from there, I have half bracket 1. Okay, we have this is 1 minus 0.5. Half is 0.5, and then you have 0.001. Okay, let me still use block bracket here to finish up. This will give us half brackets 1 minus, if you multiply this and this, you're going to have 0.0005. This is what you will have. Okay, I would love to finish up there. Okay, so from here, I'm going to have this minus this. I'm going to use the calculator. I'm going to use the calculator from here. 1 minus 1 minus 0.0005 is giving me, you have 0.5. I'm changing that 1 over 2 to 0.5 times 0.9995, which multiplies into 0.5, to give us 0.4975. Remember, we are to approximate this. We are to approximate it to 4 significant figures from the question. So to 4 significant figures, we have 0.4998 as the result. So you can go ahead to use calculator to verify that this approximation is exactly correct. If you use calculator to punch that, you will find that you will see this figure showing that both the calculator figure and the approximated figure are of the same magnitude.